This is the final video pertaining to the concept of shift registers. In this video, we will look at some very simple exercises that will give you an idea of how shift registers operate, the functioning of shift registers. So, problem 1. The content of a 4-bit register is initially 1101. The register is shifted 6 times to the right with the serial input being 101101. What will be the content of the register after each shift? Right? So we start with an initial setup and we give this register this input, serial input. And the question is, what will be the content of the register after each shift? We're going to shift it 6 times. And this is how we do it. It's very simple. Initially, our 4-bit register had this value given in the question 1101. This is the initial value. Now we will start inputting the bits from this sequence of bits, right? So the first input is 1. We start from this edge. All right. The first input is 1. This is shifted into the register. All the bits are shifted one position to the right. So 1101, and then 1 is coming from this end, and we get 1110, and then this bit will be lost, right? This is how it works. The next bit that we get is 0. So 0 comes in, 1 moves here, this one moves here, this one moves here, 0 is added, this 0 is lost. Then the next bit comes in, this one. So this moves here, this moves here, this moves here, this 1 comes here, and this bit is lost. And we'll keep doing that. Then the next bit comes in, the number is shifted once more. And the next bit comes in, and the number is shifted once more. And this bit comes in, and the number is shifted once more. So we started from 1101, and then we had this input stream, and finally we have this. So this is the final content of our register, and these are all the intermediary shifts, the results after each of the shifts. And that's what the question was. Simple enough, right? Now, problem 2. What is the difference between serial and parallel transfer? Using a shift register with parallel load, explain how to convert serial input data to parallel output and parallel input data to serial output. Again, very, very simple. The difference between serial and parallel transfer, you know that already. In case of a serial transfer, 1 bit is transferred at a time and shifting is involved. In case of parallel transfer, all bits are transferred at the same time. Now this transfer pertains to both input and output. Serial input as well as serial output, parallel input as well as parallel output. The point is, in case of serial transfer, 1 bit at a time. In case of parallel transfer, all bits at the same time. And since it is 1 bit at a time, shifting is involved. The second part of the question was explain how to convert serial input data to parallel output and parallel input data to serial output. Again, very simple. If you had to convert serial input to parallel output, what would you do? Input the serial data into the register by shifting, naturally, and output the data in parallel. So as long as you're shifting the data, as long as you're inputting the data into the register, the outputs are disabled. And once all the data is in the flip-flops, you just output them all together at the same time. And if I had to convert parallel input data to serial output, you just load the data parallelly, put all the bits into all the flip-flops at the same time, right? And then output the data 1 bit at a time using shifting. So whatever data was in the 4th flip-flop, if you're talking about a 4-bit flip-flop, for instance, then whatever data was in the last flip-flop will be taken out. That bit will be taken out, and the rest of the bits will be shifted towards the right. And then next bit will be taken out, and the next bit, and the next bit. You already know this, all right? Problem 3. A ring counter is a shift register as shown below. This one. With the serial output connected to the serial input. So this is a 4-bit shift register, which they're saying is going to be used as a ring counter by connecting the output back to the input. Starting from the initial state of 1000, list the sequence of states of the 4 flip-flops after each shift. So basically you have to write down what states this register, this counter based on this register is going to go through starting from the initial state of 1000. Again, this is very simple and you already know this. So start from 1000. Each time the bits will be moved one position to the right. So the next time you get 0100, and the next time you get, at the next clock pulse, you get 0010, at the next clock pulse you get 0001, and since this is going to be fed back into the system, you get back to 1000, and that way you will have counted 4 clock pulses going from 1000 back to 1000, right? So this transition happens at the first clock pulse, this transition happens at the second clock pulse, this happens at the third clock pulse, and this happens at the fourth clock pulse. So this is a 4-bit shift register, and it should have counted to 4, and you can see that it does count to 4 after going from 4 distinct sequence of bits. That's all you had to do. You just had to list the sequence of states. And this is where we conclude this video session. In this particular one, we discussed and solved 3 exercises related to the operation of shift registers.